After watching the process of producing giant gear shafts in Pakistan, you understand why Pakistan is called the land of machinists. They have produced special gear shafts that normally can only be made with advanced technology. Pakistan managed to do this without modern technology. They do everything by hand to create these special gear shafts. Pakistani workers don't even need any tech assistance. They only use manual forging techniques to accomplish this feat. Now, let's see how Pakistanis produce these giant gear shafts. At the raw material gathering point, they use large gear shafts from retired ships as raw materials for forging the gear shafts. Next, they use saws to cut the large shafts into steel bars for forging. After cutting, they transfer the 1-ton steel bars into a giant furnace. They immediately light the furnace using firewood as fuel. 3 workers continuously add firewood to the furnace. 1 worker controls the fire, activating the furnace's air blower to achieve temperatures above 1000 degrees Celsius. After 5 hours of heating, the steel material is fully heated. The worker uses a hook to open the furnace door, revealing the glowing red steel material. Then, the first 2 workers take wet cloth bags as insulation tools to protect their teammates from the heat radiation. The teammates behind them work in sync, using a large steel wire to clamp one end of the steel bar. Together, they pull the steel bar out of the furnace. Next, they use the lever principle to lift the glowing steel bar. They transfer it to a 100-ton forging machine. Next, they start the forging machine and begin forging the steel bar. There is a saying, to strike steel, you need steel. Pakistani workers only wear cloth clothes, which offer minimal protection. To withstand the high temperature of the glowing steel, they must have a steel will. Furthermore, to successfully forge the giant steel bar, they need a reasonable strategy. The workers arrange themselves in a T-shaped formation. 2 people on each side, and 6 people in the middle. 4 people in front control the rotation of the steel bar. 6 people in the middle control the forward and backward movement. In this way, the workers can accurately control the hammer strike position. When the steel bar is forged into a cylinder, an old worker with a white beard takes out a homemade tool. He uses a hammer to make an indentation on the steel bar to mark the gear shaft body. Once the indentation is made, the steel bar turns dark red, indicating the temperature has dropped. The ductility has reduced. The steel bar needs to be reheated. When reheating the steel bar, to avoid damaging the furnace, it must be removed. Then, close the furnace door and continue adding firewood. When the desired hardness is achieved, the steel bar returns to a red state and can proceed to the next step. Finally, the steel bar is heated to form the large gear shaft. This step is complete. The worker in charge of the fire activates the air blower system to increase the furnace temperature. When the temperature reaches the highest point, the workers open the furnace to raise the steel bar. They close the furnace door to prevent heat loss. This heating process takes about 1 hour. After 1 hour, the steel has been fully heated. The worker opens the furnace door and prepares to remove the steel. The workers hold one end of the steel bar tightly together. They move the glowing steel bar to the forging table. Then, they remove the wire and replace it with a chain. The forging of the gear shaft begins. First, they forge the indentation into the square end of the shaft. Then, they continue forging the edges to shape it into a cylinder. During this process, the shaft still has many flat surfaces. The workers use a caliper to measure the diameter of the shaft. When the measurements are correct, they use consistent forging rhythm to eliminate the flat surfaces. This turns the shaft into a uniform mass. Very quickly, the gear shaft is successfully forged. Next, they remove the steel from the forging machine. They use a steel frame to hold the shaft. Then, they reheat the remaining end. After reheating, they return it to the forging machine. First, they use a hammer to fix any dents. This makes the surface of the shaft flat. Next, a homemade tool is used to create a forging mark on the shaft. Then, the rest of the shaft is forged. The workers continue their work. Despite the tough working conditions, they remain optimistic. This reflects their diligence and optimism. This forging tool has a long history. It is a legacy from the British colonial period. This forging machine is powered by steam. The worker must sit on the machine to manually control the hammer. They control the hammer's up and down motion to forge. This also leaves a strong impression. Despite the tough work and harsh working conditions, they maintain their enthusiasm. Indeed, it truly reflects the hard work and optimism of the Pakistani workers. This hammering machine is also of great historical value. It is a legacy from the British colonial era. This machine operates on steam. It requires someone to sit on it to manually control the hammer. They control the hammer's up and down motion to forge. After 2 hours of forging, the remaining part of the shaft is finished. The steel billet has completed its first transformation. It needs to cool overnight. The next day, machining begins. The worker installs a cutting tool on the shaft. They use a cutting tool to remove the excess at both ends of the shaft. Once the shaft is cut, machining for the gear shaft begins. Since this is a large shaft, a heavy-duty lathe is needed to handle it. The lathe's blade is sharp as butter. The lathe spins, creating a smooth surface. After machining the surface of the shaft, they continue machining the steps on the gear shaft. Machining the steps is very challenging. If not careful, the tool can break. Therefore, this step must be entrusted to skilled workers to ensure accuracy. The lathe workers in Pakistan are very skilled. With just a caliper and a measuring tape, they can guarantee machining accuracy. After 1 day of machining, the rough steel billet has become an intricate gear shaft. The gear shaft has completed its second machining process. Next, the workers tie the two ends of the shaft with steel wire. They lift the shaft off the lathe. Then, the gear shaft is transferred to the gear cutting machine. They mount the shaft on the machine. The gear cutting machine slowly lowers. It tightly clamps the conical end. Then, the gear shaft is transferred to the gear cutting machine. Once the gear shaft is positioned correctly, the cutting machine slowly lowers. It tightly clamps the conical end and secures the gear shaft on the cutting base. Then, the machine begins to operate. The sharp alloy blade on the cutting machine starts cutting the teeth for the gear shaft. Red liquid is used to cool the blade. This is a cutting fluid lubricant. The cutting machine rotates at a certain speed, rotating the gear shaft. This ensures that the gear shaft and the alloy blade move in sync. Thus, the alloy blade will cut perfect teeth and grooves on the gear shaft. Finally, the gear shaft is completed. At this point, the process of producing the gear shaft is finished. What do you think? Can a gear shaft made entirely by hand in Pakistan be compared to the advanced industrial technology of developed countries?